So what is merge sort? It's an algorithmic approach that we call divide and conquer. So before covering the theory, let me show you a visual representation of how it works. It will help you to understand the theory better. So initially we have a sequence of data like this. Okay, so this is an array, and what we have to do, we have to sort this array, and the sorted version will look like this. Okay, so 1 6 9 15 18 26 32. So this is the sorted array. So what we will do, okay, we will divide the array into small part. Okay, and then after dividing the array, we will then again merge the array. Okay, so that means first আমরা অ্যারেটাকে ছোট ছোট করে ভাঙবো যখন পর্যন্ত অ্যারে সাইজ 1 হয়ে যায়, and then যখন array size 1 হয়ে যাবে আমরা হচ্ছে অ্যারেটাকে আবার জোড়া লাগাবো. So our algorithm start from here. This is the step number 1, this is the first step, and this is the last step, or we can say this is the input and this is the output. And how this algorithm starts like this, and it goes like this. Okay, so let's see how it works. So what we will do, we will divide the array into small part until the array becomes the size of 1. So what is the size of this array? 8, right? 1 2 3 4 5 6 7 8. So we will divide the array into 2 equal parts. Okay, so 4 4. So this is my first array, this is my second array. So we have divided the array into 2 parts. Then again we have another array, we will divide it into 2 parts. Okay, so this is an array of size 4. So the array will be divided into 2 and 2. So now same way this array will be divided as well, and we'll have, now we have 4 array. Okay, we have a 4 array of size 2, and then again we will divide the array into small part, an array of size 1. So now after this stage, what we have is an array, is 8 array of size 1, and this is our first stopping condition for divide. That means we will divide the array until we have a array of size 1. So this is the final stage of divide approach. So we have divided the array that was given to us, okay, into small array of size 1, and this is the first result of divide step. Now what we will do, okay, after, when we will see that our all the array is divided into small part of size 1, we will start merging them. Okay, so when we are merging the arrays, যখন আমরা অ্যারেগুলিকে জোড়া লাগাবো, we will use another approach. Okay, that approach will be, in this case we will make sure the array is in a sorted order. Okay, so for example, if I start with this one, so this is the this was the array, okay, that we actually divided. That means this was 8 array of size 1. Now when we are merging, okay, so we will compare these two. So among these two, which one is the smaller? The smaller will go first, the larger one goes second. So as we know, 18 is the smaller and 26 is larger, so obviously 18 will come first and 26. But look at this two, 32 was first, okay, and 6 was after 32. But whenever we are merging these two array, okay, we actually keep 6 first and then after this 32. Then again we have 43 and 15. So whenever we are combining these two array, 15 will come first, 43 will go next. Same for 1 and 9. So we have, what we did when we are merging the array, so we actually sorted the arrays in a bit. So all these arrays that you see here, array of size 2, array of size 2, array of size 2, array of size 2, all them are actually sorted. Okay, so this is a sorted array of size 2, this is a sorted array of size 2, this is a sorted array of size 2, and so on. Again, whenever we are merging these 4 arrays, okay, so I will merge this 2 array. Let's first focus on this 2. So what I will do, if you look at this merged array, okay, the smallest, which one is the smallest among these 4 elements? This one, right? So this one will go first. Then which one is the second smallest? This one. This will go next. Then the third smallest and the fourth smallest. So this small array that you see of size 4, this is already sorted. Same will be applied here. Okay, so this will also be sorted. So in every stage, whenever we are combining the array, we are actually sorting the array. And finally, when we have this total merged array, we have a totally sorted array. So in short, what we did, we took an array, we divided the array until there's only one element, okay, and then we actually combine the array. But whenever we was combining the array, we actually imposed a new condition, that the condition was whenever you are actually combining the elements, you have to make sure they are sorted. And we actually applied steps of sorted algorithm. Okay, now you might the first impression that we get is this is too much hassle. Okay, we are dividing the arrays, we are creating new arrays, and then we are joining these arrays. There are a lot of operations going on. Okay, here you are, every time you divide the arrays, you have to create new array. That means you have to create new data structure. Then from those data structures, you have to again create sub data structure. Okay, and so on. Secondly, the recursive call. All this operation actually gets done recursively. That means whenever this array calls the function of sorting, okay, let's assume this array calls the function for merge sort with 8 elements. What is this function does? This function recursively calls two other function for sorting the array of size 4. Sorting the array of size 4. Okay, this function calls two other function. Okay, F2, F2. This array also calls two other function, F2, and goes on. This calls F1, F1. And after this F1 is solved, okay, the results go back to the F2, the F2 result go back to F4, and whenever the F8 function returns, okay, it actually have a sorted array. Now, this is the basic idea of how merge sort work. So we divide the array into small part and then we sort it. That's why it's called divide and conquer. Okay, so instead of sorting 8 elements, what we do is instead of sorting a huge array, we sort small arrays. Okay, and this actually overall performance actually gets improved. Okay, so let's see the definition now. So this is a divide and conquer approach. This is a recursive in structure. So one function will call another function. We will wait for the result of another function that divide the problem into sub problems that are similar to the original but smaller in size. So here, what we did, we had a problem of size 8. So we divided into problem of size F4, F4. So these are the same problem. Okay, so the problems are of the same size, okay, but smaller. Okay, so then the sub problems, conquer the sub problems by solving them recursively. And if they are small enough, just solve them in a straightforward manner. So basically just solve them one by one. And this last line, okay, this actually means that when you have a size of 1, okay, you can just directly compare these two. And finally, combine the solutions to create a solution to the original problem. So what we do after sorting this array, if I take you back here, if this array is sorted, this array is sorted. So this two is combined to create another sorted array. And finally, when this two is combined, we have our sorted array. Okay, so we are combining the small solutions to get the original result. So here, the sorting problem, divide the n element sequence into n by 2. Okay, sort the two subsequence recursive using merge sort, and combine the merge sort merge the two sorted subsequences to produce the sorted answer. So divide and sort. So these are the bookish term. Okay. Now let's see how the algorithm actually works. Okay, the first function that is called merge sort. They're actually in this sorting algorithm, you actually have to use multiple functions. Okay, I will come to that, but this is the main function, the merge sort function. Okay, let's see what is the input of this function. The input is here APR. Okay, here A is our array. Okay, then P and R are basically means that if you want to divide the array, from which position to which position you will divide it. So if I go back to the last example that we just saw, so initially when this function will start, okay, this will call one, the function name will be look like something like this. Let me write it down. If, let's assume the name is if our whole array, that is A1, comma, let's say 0, 7. So our first index and our last index. Okay. Then whenever I call this function, okay, this will be like if, so I will divide the array A0, 3. And this function will look like this, if, same if function, A, comma, 4, comma, 7. Then if I call this function, it will look if, again, if A, 0, 1, if A, comma, 2 comma 3, and it will keep going on like this. You can understand, right? So this way you will all the functions will be called. Okay, let's go to the next one. So here, so first we'll call the merge sort function. So first we check whether the p is less than r. Okay, that means you see here what we're doing, we are calling the function, okay, a p q and q plus 1r. So you see a is basically, initially a means the whole array, p is the first index where we should have the first array, q is the second index. So a 0 3, then this one is basically q plus 1, that is 4, and this r means 7. So what we did, we divide the arrays using these two indexes. And how we calculate q? Q basically the average of p plus r. So যদি সহজভাবে বলি যে আমার লেফট এবং রাইটে দুইটা মাঝামাঝিটা হচ্ছে q. So a থেকে p হচ্ছে 0 থেকে মাঝামাঝি 3, আর এটা হচ্ছে 4 plus r শেষ মাথা পর্যন্ত. Just the way we did in the bubble sort, in the binary search. Okay, and then there is another function. Okay, that function is called merge function. And in the merge function, what we do, we actually combine these two arrays. Okay, the array that we called, we combine this a p q r. Okay, so we combine, merge these two sorted arrays. Now let's see the what is the magic of the merge function. Okay, so this merge function, if you look closely, this is nothing but what it's doing is basically taking two array and it's just adding them up. Okay, so you see it is n1 n2. So n1 means basically the left array, and n2 means the right array. Okay, so what it does first, it copies all the elements into the left array and the right array. So we have two arrays, left array and the right array. And initially, if you go look at this if else function, what we do, we check that in the left array and the right array, which one is the smaller. So we insert the smaller one and update the index. Let's go to the present example here. So here we have this left array. Okay, we have this right array. Now
এটা ফাংশন নাকি আমাদের বানাতে হবে ওইটা?
You have to make it. Okay, everything we have to write from scratch. Okay, now so let's assume that I will apply the merge function, okay, in this two array. Okay, and I will get this result. Okay, so in this part I will apply the merge function. So what it will do, it will first, this will be our left array, this will be our right array. So what it will do, it will compare the first element of left array and the first element of right array, and which one is the smaller, the first element of right array, right? So it will insert right array to our merged array, and the index of right array will be increased by 1. So now initially the both index was 0 0, but as soon as I have taken an element from this right array, the index will become 1. So that means next time I will compare this element and this element. Okay, and in between these two, which one is smaller? Obviously 18. So 18 will be passed to this array, and the index of this array will be increased to 1. After that, I will compare this element, that is 1, and this element, and between these two, this one is smaller, so this one will be sent to here. So if you practice this at once, it will be very clear, but I think you got the idea of how merge sort work. And this is how the merge function works. Now this is another example. Let's go step by step. So initially we have this array, okay, and we can, we divide it into this two part. Okay, and one thing you will see that if you try this one on your own, okay, after certain steps you will understand how the merge function work properly. Finally, we have this analysis. So the running time of merge sort algorithm, okay, it's actually, there are different ways we have to calculate it because there are a lot of things going on. Okay, so first, what is the result of the running time? The order of n log n. So this is the complexity of merge sort. So, and you can see this is actually less than binary search and bubble sort and other sorting algorithms. Now, what is this order of 1 or this tree? So you see here, we have 3 different types of operations. Okay, first we have to divide the array into sub-arrays. And for that, we have to have a complexity, right? So the complexity is constant time, because we are just dividing. What is the size of the array doesn't matter. This is just two commands, divide, divide. Okay. Second, solving the sub problems, it actually takes a little bit of time because you have to compare the elements. Okay, now normally if we have an array of size n, if I want to solve that array, we need an Babosor algorithm, right? But if you look on this one, this example, the advantage lies right here in front of your eyes. So initially, if I ask you that, hey, Shakil or Khairun Nahar, how many comparisons do we need? Okay, so you will say, sir, you cannot say for sure that, sir, I need 2 comparisons or 2 comparisons. Okay, you will say, sir, in the last step, I need 8 comparisons. Okay, then here I need 8 comparisons, and here again I need 8 comparisons. So basically at every step, okay, you have to compare these 2 elements, then one of them will go. So comparison number 1, let's assume this one actually went. Okay, so then you have to compare 6 with 9, so comparison number 2. Okay, then this one will go, and from 18 and 9 you have to again compare this 2. So this is our third comparison. And if you keep counting like this, that from after 9 you have to compare 15 and 18. So this is our fourth comparison. So you see that for each element that is getting inserted into this array, we have to do at least 1 comparison. So here we have to do 8 comparisons, here we have to do 8 comparisons, and so on. So let's go back to there. So after the calculations of time complexity, we'll have order of n log n. Okay, and so combining the elements is actually order of n, because every step we have to take n comparisons, okay, to merge them. So this is our analysis of merge sort. Now you can actually understand the difference between merge sort and other algorithms. The first thing is merge sort actually is a time efficient, but it is not memory efficient, because you need to create a lot of arrays. Okay, just think about this example. For solving an array of size 8, you had to create 2, 4, 6, 8, 14. You had to create 14 more arrays. Then you had to merge them as well, right? So if you have a data of size 1000, how many arrays you have to create? So this is not memory efficient. But if you compare the time, okay, so you see the best case scenario of Babosor is order of n, average order of n square, or square order of n square. Okay, for the merge sort, order of n log n, order of n log n, order of n log n. That means the size of the array, or doesn't matter how the data are, merge sort always takes the same amount of time, best case, average case, and worst case. And most cases, its time is much better than all other cases. So we have already learned the bubble sort, insertion sort. We have now seen the merge sort. In the next class, we'll see heap sort. Okay, and if we have time, we'll also go for selection sort and the quick sort. So let me end our today's class here. Our time is already over.